Yes friends, we were on solved examples. I am on page number 128 of your textbook. Solved examples. First solved example I am taking. If sine theta is equal to 20 upon 29, then find cos theta. We are given sine theta value, we have to find cos theta value. Remember my identity number 1, sine square theta plus cos square theta is equal to 1. We will use identity sine square theta plus cos square theta is equal to 1. That was the identity I got you. Okay. Now put the value of sine given, square it, plus cos square theta is 1. Changing the sides, cos square theta is 1 minus 20 upon 29 square. This I have taken on this side. Now 1 minus 20 square, 20 into 20 is 400 and 29 square is 841. 29 multiplied by 29. Please learn the table of squares up to 30. Please start daily learning at least 10. I know you know 10 tens are 100, 12. After that, it's difficult for you. Please start learning 10 every day. Okay? It will help us. Otherwise, you will start multiplying 29, multiply by 20. It is going to waste our time. If the question is of 1 mark and we are going to take 10 minutes, you are wasting your own time. Please learn the squares. Now, solving this further, it is 841 minus 400 upon 841. How did I get this? You can put it like this. Take LCM, whichever method you like, which you learned in the 8th and 9th standard in algebra. Okay? When you minus this, you are seeing this gives me something like this. Okay? So I got 441, but this is cos square theta. This is cos square theta. Please don't forget, I want cos theta. So I will take the square. So I will take the square root of this, I will take the square root of this. So I will get cos theta is equal to. Now, as I have been telling you, must learn squares. Now you have to learn square roots also up to 30. Now you see, we must know all square roots in this case. Now 841 though we have already knowing 29 and now we have got 400, we need a 441. Okay, we can do a guess method etc. But if you learn, it will become fast. Now at least I can know from 1 and I've taught you last year. There has to be 1 in the end and near 400 is 20. So 21. Okay. Or it can be 29 into 29 to give me 1 in the end. But then I am closer to 400. By taking 29 I am closer to 300. 300 into 300 is 900. So that's why by guess 21 is the right guess. Or you can find by table or square root method. If you use long form you are wasting your time. Please learn. So this is 21 and this is 29. You can see this is from where I got this. I need not solve it. So don't waste your time solving everything. Okay, 841 is already on top, which was 29 square. So 29. So I got cos theta. What I have to find? Cos theta. They will give me 1 marks for this. Okay? So please learn the method in shorter possible form so that you don't waste time. You can do 20 steps. Of course, I can do by this, I can do by right hand. Don't waste time. The marks are not worth wasting more time on. Okay? I hope it is clear. So sine theta is given, we have to find cos theta. I will use identity. Sine square theta plus cos square theta is 1. I will substitute sine theta ka value and put it in that identity. I will change the sides because I need cos and I will substitute the value. I will open the square. I will take LCM. I will take square root and I will get the answer. This is how we have to do this. So this was your first technical sum of trigonometry. Okay, we will go further. If you have still difficulties, please let me know. Okay? Perfect. I will go for the second one. Okay? Now, I am on page 129 of the textbook. I'm going page by page so that you can follow where I am. On page 129, I have the sum. If sec theta is equal to 25 upon 7, find the value of tan theta. They have given me sec and I am supposed to find tan. Look at identity number 2 I taught you, okay, in the earlier lecture. The last lecture we have seen identity 1 plus tan square theta is sec square theta. Identity number 2. You don't have to write identity number 2. I am writing so that you know from where I am getting what you have to learn. You have to write only this much. It's a universal truth. Identity means always valid. One. Now I have sec theta. Okay, and I need tan theta. So tan square theta is, okay, as we have done last time, sec square theta minus 1. Okay, now I will put the values. Sec theta is 25 upon 7. It is square minus 1. I will open it up. 25 square, okay, 6, 25, 7 square, 49 minus 1. Please learn the square, write it down in a table and kindly learn. Okay, otherwise it will waste time. I keep reminding you. Now you have the time. 625 minus 49 upon 49. Again, how I got this? You can take LCM. Okay. When I subtract, I get 576 upon 49. Now, as you very well again know, to get 6, and I'm going to make a root. 4 4s are 16, so I need a 4. So I will need a 4 here. 49 I already know from here that it is 7. I'm not going to waste time and I'm going to take out square roots. So that I am getting direct tan theta because I need tan. I don't need tan square. Okay, so I will remove square roots. Now 576, because 625 is 25, I have to go to 570, so I have to be near 25. My answer is 24. So I get 24/7. This is my answer and I get 1 mark. Going through the sum again. Sec theta is given. We have to find tan theta. We have learned the identity. 1 plus tan square theta is sec square theta. I need tan theta. So I will keep tan theta on the left hand side. I will take 1 on the other side. Otherwise you can substitute here also, but you will have to change the sides. This is, put the value of sec theta, square it, minus 1. 25 square is 625. 7 square is 49. And when I minus, subtract, I get 576 upon 49. I remove square root because I don't need the square. Square root and square cancel. I will get tan theta. And 24 is the square root of 576. 7 is the square root of 49. This is the answer and you will get 1 mark. Please note, all sums are quite similar. This is how we solve. Okay? You can, the book shows you, you can do by other methods also. I do not suggest, it will waste time. Their steps are longer, there are calculations and it takes time and mark is only 1. Okay, so we do not suggest learning other methods. Please learn the identity. Okay, we will see the next sum. Okay. Now, again on page 129 only, they are given if 5 sine theta minus 12 cos theta is equal to 0, find the values of sec theta and cosec theta. Okay, this is what is given in the sum. If 5 sine theta minus 12 cos theta is 0, find the values of sec theta and cosec theta. How to do the sum? First, have they given me value of sine theta? No. Have they given me value of cot theta? No. Then how will I start using my identities? So, first thing, 5 sine theta is equal to 12 cos theta. Remember, I changed the sides. Okay, I have subtracted. Okay, 12 cos theta. I added 12 cos theta on both the sides. So it cancels on this side and that one remains when I add to 0. Or simple language, I have transformed it to the other side. So this is our first step. Second step, I have sine theta divided by cos theta is 12 by 5. This went here and this 5 went there. I switched the numerator to the denominator on the other side and I switched the numerator to the denominator on the first side. So I will get like this. All this is your 5th, 6th, 7th, 8th standard algebra. Okay, now tan theta is equal to 12 upon 5 because sine theta divided by cos theta is 12 upon 5 is equal to, tan theta. This is also we have learned in the basic ratios. Okay, so this is what I get. So now I have a value and I have to find other values. So this is 2 marks. 1 mark to convert, 1 mark to solve. Okay, now going ahead. Using the same identity like last time. 1 plus tan square theta is sec square theta. 1 plus 12 upon 5, the whole square, is sec square theta. 1 plus 144 by 25 is sec square theta. This is 25 plus 144 upon 25 is sec square theta. And as you can see here, 169 upon 25. 4 plus 5, 9, 14 plus 2, 16. And sec theta, I will take out square root. Sec theta is square root of 169 upon 25. Again, I told you, please learn the square table and square root table. 13 13s are 169, 5 is 25. Okay, so I get this. This is my first answer. So answer 1. Now I need cosec theta. How will I get cosec theta? Okay, that is a big question. Now, do not forget, I have given you that ratios are inverse of each other. 1 upon sec theta is cos theta. Please look at the basic ratios. The 3 ratios are primary, 3 are inverse. So when I invert 1 upon cos, I get sec. So it means 1 upon sec is cos. Okay? 1 upon cos is sec. Therefore, this goes on top, this comes down. 1 upon sec theta will be cos theta. Inverse. So, sec theta I have 13 upon 5. So 1 upon will become 5 upon 13 is cos theta. I don't need cos theta. Okay? I need, you can see from the question, cosec theta. I am supposed to get cosec theta. For cosec, I need sine. I do not need cos. I will use identity number 1. Sine square theta plus cos square theta is equal to 1. Or sine square theta, therefore, is 1 minus cos square theta. 1 minus 5 upon 13, the whole square, which will be 13 square 169 minus 25 upon 169. This will be 144 upon 169. Therefore, sine theta is 12 upon 13, taking out the square roots. Learn the square root tables. 144, 12 12s are 144, 13 13s are 169. Now, 1 upon sine theta will be cosec. Therefore, cosec theta is 1 upon sine theta, that is 1 upon 12 upon 13 or 13 upon 12. Answer number 2. This is how you will get your 2 marks. Okay, we'll go through it once again. 5 sin theta minus 12 cos theta is 0. Take the minus 12 cos theta on the other side. So 5 sin theta is equal to 12 cos theta. Divide sin theta by cos theta, divide 12 by 5. Change the signs. Numerator will become denominator and denominator becomes numerator. Sin upon cos is tan. So we have got the first value because basic ratio. Identity number 2. 1 plus tan square theta is sec square theta. Substitute, okay, solve and you will get sec theta. Now 1 upon sec theta is cos theta. Why? You don't have to write all these reasons. I am explaining these in details. Okay, so I get cos theta ka value. Now I'll use identity number 1. Sin square plus cos square, theta is 1 and I will get that sin theta is equal to 12 upon 13. Cosec is 1 upon sin is 13 upon 12. Answer 1, answer 2, 1 mark, 1 mark, I will get 2 marks. So please have a look at this sum. Practices 2 times, same sum but they put 2 times. Nothing great about it. Okay, just to increase the marks, they will increase the number of steps. Sum type cannot change, steps cannot change. So I hope you have understood the solved example. We will go for the next solved example. Okay, again if you have any difficulties, you will have to learn to take the square roots, you will have to learn to take square, you will have to learn to subtract, you will have to learn to take LCM. Do not forget your 9th standard. You still have difficulties, convey, start gripping now. What you don't know, don't say I will learn later, I will memorize. These things don't help in mathematics. Please get back. It is as simple as that. There is no shame in learning. You may be a slow learner, but you will definitely catch up if you learn. If you don't learn, you will never catch up. So there is no question of hiding. This is not 9th standard, there is a board exam. Same exam for everybody. They don't see who has learned more, who has learned less. More practice, more marks. Okay? And we as teachers are there to make you practice. Let's look a little more complex calculation. I am on page number 130 of the textbook. The sum says cos theta is equal to root 3 by 2. Find value of 1 minus sec theta upon 1 plus cosec theta. See how it looks complex, looks nothing. You see it will be the same type and we will be solving. Please do not write short forms in the exam. Okay, never write short forms in the exam. You are not teaching. Okay, so please do not use. Okay, now I need sec theta, I need cosec theta. Then I can find the answer. I have to subtract, I have to add 1 to it. And I have cos theta. So first we know cos theta and sec theta related. 1 upon cos theta is sec theta. Okay, so 1 upon root 3 by 2 is sec theta. Now we have to invert, it will become 2 upon root 3. So this is step number 1, not answer number 1. First we have to find the value of sec theta. Okay, next, in the last sum only I have taught you how to find sin theta from cos theta. I need sin for cosec. Cosec is 1 upon sin. Okay, so second identity, sin square theta plus cos square theta is equal to 1, or sin square theta is 1 minus cos square theta. I take it on the other side. It will simplify easily. This is 1 minus cos theta root 3 by 2 u square. Now this will be equal to 1 minus root 3 square is 3, 2 is 4. Again, like LCM you take, this will be 4 minus 3 by 4. And this will be 1 by 4. Now I need sin theta. So sin theta is square root of 1 by 4. 1 ka square root 1, 4 ka square root 2. So this is my second step in finding the parts of the sum. Please have a look. Now the sum becomes simple. Okay? But I don't need this. I need cosec. 1 upon sin theta is cosec theta. So that is 1 upon 2, that is equal to 2. This is my ready-made second step. I'll remove that from here because otherwise numbers will become too many. So I have got one value, I've got the other value, now I have to substitute. Now, therefore, 1 minus sec theta upon 1 plus cosec theta. This is the sum. 1 minus sec theta is 2 by root 3. Cosec theta is here. 1 plus 2. Now this is, here it appears simple. 1 minus 2 by root 3 and there is a 3. This simplifies to this level. Okay. Now, how to simplify further? Looks difficult, no problem. Same LCM method, root 3 minus 2 upon root 3 upon 3. Again, 3 to make both the fractions. Last year I taught you A upon B upon C upon D. Whenever you have a double fraction dividing, A is equal to AD upon BC. You don't have to do like this every time, okay, and waste your time. Direct, please remember this formula. It will come many times in our sums, solving steps. So now A, D, B, that is second, and C. So directly root 3 minus 2 upon root 3. Okay, do not waste more time in solving, is my suggestion to you. Okay, now this is how it goes. Okay, 3 root 3, sorry. Okay, there's a 3, there's a 3 root 3. This is how to solve. Some is not difficult, some looks difficult. Okay, we don't have to write. Now in exam, I will not write this step. I will directly, now I know how to use identity. I will directly use. I will not write this. I will directly write sec theta is equal to 1 upon cos theta and directly start here. I don't need to write everything in the exam. So it will save a lot of time. Here I am explaining in details, slowly. There you have to solve. Okay, so you don't make the steps longer, more. See the marks. If the mark is only 1, solve it in 2 or 3 steps. If the mark is 2, solve it in 4 or 6 steps. You don't have to take 14 and 16 steps. You are wasting your time, which can be used fruitfully to solve other sums. Okay, so this was the sum. We will see another example. On the same page, I have the sums will increase a little complexity, but they are not complex. Show that sec x plus tan x is equal to root of 1 plus sine x upon 1 minus sine x. Okay. Now how to do the sum? Left hand side, you can take any side first. Okay, is sec x plus tan x. Sec x is 1 upon cos x. Tan x is sine x upon cos x. To help you remember, don't write in the exam, you have to memorize. Sec x is 1 upon cos x and tan x is sine x upon cos x. Don't waste time, start practicing and memorizing. Now bottom denominator, both are common. I will get one term, I will get the other term. Left hand side. Now I need a square root. So how do I get a square root? Square root and squares are enemies of each other. So if I write it like this, 1 plus sine x upon cos x, the whole square, and I put a square root, it will look something like this. Okay, that's first. So, and separating it a bit further, the roots, so I will get root of 1 plus sine x, the whole square, divided by cos square x. I have separated the squares and distributed it to both the terms. Okay, now a plus b the whole square is a plus b multiplied by a plus b. You have to multiply 2 times, you get a square. So 1 plus sine x into 1 plus sine x. And cos square x, please remember, is 1 minus sine square x. because sine square x plus cos square x is one identity number 1. So I get this much. Okay, we are ready to hear? Perfect. Okay. Now, going further, top I cannot solve because both are same terms. Nor you should if you multiply, you get that back again. Don't do anything else to it because it is already simplified. Now, look at this as a square minus b square. 1 is 1 square. A square minus b square is a minus b into a plus b. I'm writing for your knowledge, don't write in the exam. A square minus b square is a minus b, a plus b. Don't forget your 8th standard factorization chapter. Okay, this and this will cancel and this will give me root of 1 plus sine x upon 1 minus sine x, and you can look here, this is equal to right hand side, hence proved. So it looks so difficult, so simple. We'll go through it once again. Okay, have a look. Sec theta plus tan theta is equal to this. We have to prove left hand side is equal to right hand side. Take any side. I chose the left hand side. Sec is 1 upon cos, tan is sine upon cos. Don't write this in the exam. Remember. Now, if the denominator is same, numerators can be added. Then I need a root. So if I put a root, I must square. Square and square roots cancel each other. Now, I will give the squares individually. And a plus b the whole square, a plus b, a plus b. A minus b the whole square, a plus b, a minus b. These two terms cancel this and this. And this is what I want. And I have proved left hand side is equal to right hand side. Practice it 2-3 times. Get fluent, get speed, which is more important, without making mistakes. Don't cancel. First write like this and then don't do any rubbish work. If you don't like a step, cancel the step, write the step again. Don't try making smudges and changing numbers. It will never help you in the exam. It will confuse you more. So this was looking so bad but finding it easy. We will look at the last example for solved example. And then next we will look at the exercises. Okay? And on page 131 of the textbook. Okay? So this unit will only have solved examples, so that first you practice all the solved examples. They teach you all the techniques, and then next lecture when I'm going to do the exercise, you should be ready with the techniques. Okay, because we'll do faster. There are too many sums in the exercise. Eliminate. Get rid of theta from given equations. Here we don't want theta. What are the equations? X is a cot theta minus b cosec theta, and y is a cot theta plus b cosec theta. We don't want the theta term, so I don't want this, I don't want these 4 terms. I must get x and y in terms of a and b. You have to eliminate theta. So first you can see this looks like a, so I will make it simpler terms, m minus n, and this looks like something like m plus n. Have a look, m minus n, m plus n. Okay, so first thing I add equation 1 with equation 2. Adding equations 1 and 2, we add these equations. So I have x is equal to a cot theta minus b cosec theta. I have y is a cot theta minus b cosec theta plus y. I brought it from top. Now I have to add it. So I will add it. Here I will get x plus y. I don't know what is x, I don't know what is y. I have to keep it variable x plus y. I get this 2 times, as you can see at the top. So a plus a will become 2a. Okay, and cot theta will remain. So one apple plus another apple becomes 2 apples. And this will cancel because they are opposite signs. So there will be nothing here. If you want, plus 0. There is nothing there. Plus and minus are opposite of each other. They cancel each other. So I will get x plus y is equal to 2a cot theta. They have told me get rid of theta. So I don't need this term. I have to get rid of this term. So I will get x plus y upon 2a is cot theta. I brought 2a on the other side. Numerator will become denominator. And I got cot theta on the other side, as you can see. So this is how I get rid of this. So this is my equation number 3. So I have reached an important step. Now, second, I will subtract. Subtracting equation 2 from equation 1. So I will write equation 2 first. I will write equation 1 afterwards. I will subtract. So this will become minus, plus will become minus, and minus will become plus, and then I add. Y minus x is equal to y, subtracting x from it. This and this will become opposite, so they will cancel, and I will get 2b cosec theta. If you want to write 0 plus, you don't write zeros. We never write zeros. Okay, but where it is 1, this will become 0. So I will get again like this. I have to convert it to the form y minus x upon 2b is cosec theta. This is my equation number 4. So this is how you have to reach the end of the sum. Now, how do I get rid of cosec theta and cot theta? I only need these answers. Eliminate the theta. I don't need this also, and I don't need the cot theta also. So, okay, I have to get rid of both. So how do I get rid of both? Now, going to the third identity, I have cosec square theta minus cot square theta is 1. Because cosec theta is 1 minus cot square theta. So I will have this identity number 3 in the 3 list of identities I gave you. So y minus x upon 2b, the whole square, minus, coming to cot theta, x plus y upon 2a is equal to 1. I have got rid of the theta. Now my equation does not have any terms in theta. You can have a look. Now you will say difficult. We are giving you 4 marks. Please see that you learn algebra. There is no trigonometry now. After this is algebra. Okay? Please see, these are algebraic to solve. So when you solve these, they look difficult to you, but I will show you that they are not difficult because the denominators are easy. See? You may now divide by 4, dividing by 4. Okay, all the terms. So I will get y minus x square upon b square minus x plus y square upon a square is 1 by 4. Okay, I will get terms like this, dividing by 4 all the sides. Okay, we have not done anything here, there, anything, something fishy. You can leave the answer like this. You can again switch this by minus. This is answer where you should leave. If you wish to solve further, you can change the minus, plus y in a minus term. So you can switch the terms, minus y plus x square upon a square. because a plus b is equal to b plus c. So it does not make a difference. So I have switched y first. So looks nicer. It does not change the answer, does not change the value. E is equal to 1 by 4. You can leave this answer, you can leave this answer. They will give you 4 marks. We will go through it once again. Eliminate theta. We don't want any term in theta. 2 equations are given. I told you look at them as m minus n, m minus n, m plus n, because both are m and both are n, we can assume. I put the 2 equations, I add them. When I add them, I get cot theta ka value. I subtract, I get cosec theta ka value. I don't need cot theta, I don't need cosec. But I have identity number 3, where cosec and cot are related. Okay, cot square theta is cosec square theta minus 1. Identity number 3, I change the side. So cosec square theta minus cot square theta is 1. Substitute the value. Cosec square, cot square, and divide by 4. You can leave it, but 4 and square are together. That's why we have done like this, and we get an answer like this. Okay, nothing more to solve. Don't try to remove square roots, because square root, if you remove square root, the square root will be on complete term. Don't try. Never remove. Try to say, I will remove the square also. It is not single term. It's got a minus sign in between. So you can't get rid of the minus. So after you square, you have to subtract. You can't subtract and then square. Okay? For example, 4 square minus 2 square. And you are saying 4 minus 2 the whole square. They are not same. You can try yourself and see. So you cannot take out square roots now, although they look very nice. I will cancel this. I will cancel this. Sorry. Because what will happen to the minus? Values are not same. Please leave it like this. Do not try to solve it further at your level. Okay? So this is where we will stop today, because I have done all the sort of examples, and next lecture we will start with the textbook exercise.